As a hospital biomedical engineer, you probably see a variety of medical equipment every day. With the growing demand for minimally invasive surgery, video camera systems have become an essential part of most operating rooms. Video cameras enable the surgeon and staff to work off a magnified image on a monitor screen. Video endoscopy has revolutionized surgery by eliminating the need for large incisions. It has also significantly improved surgeon and staff teamwork in the OR. This videotape will discuss the system as a whole and every component that contributes to the ultimate goal of a televised image. Test bench setup for non-invasive troubleshooting of the camera head and camera control unit will be presented. The following equipment works together to produce an endoscopic image on the television monitor: light source, light guide cable, endoscope, camera head, camera control unit or CCU, and video monitor. The light source provides the illumination necessary to perform endoscopic surgery. An aged lamp or malfunctioning system can cause inadequate illumination for the entire imaging system. Generally speaking, lamps should be replaced before they have reached the maximum hours stated by the manufacturer or when light drop-off is noticeable. Light guide cables carry the light from the light source to the endoscope. These cables are somewhat fragile and, if not handled with care, can be damaged. The way to check a fiber optic light cable is to look at the end of the cable which attaches to the scope. It should be clear of broken fibers or black dots. A few broken fibers have a minor effect on the transmission of light, but when 1/3 or more of the fibers are broken, it is time for a new light guide cable. Stiff fiber optic cables should be replaced. This is a symptom of fluid contamination. Endoscopes can either be rigid or flexible. Like fiber optic light guides, they are easily damaged if banged, kinked, or dropped on a hard surface. You can check the endoscope post of a rigid scope for broken fibers in the same way you check the light guide cable. For flexible scopes, check the distal end for broken fibers. Run your fingers along the scope to check for kinks or bends. The image through the scope should be centered. If the image is off-center, there may be an optical problem within the scope. The image should also be clear and in focus. A camera head attaches directly to the endoscope. The optics in the camera head focus the image as seen through the endoscope onto the camera's sensor. The camera head adapter magnifies the image for monitor viewing. The optical information is carried by a camera cable to the camera control unit or CCU, where it's processed and sent to the monitor. The CCU contains all electronic processing of the video information and control of functions like auto white balancing and auto exposure. The CCU is connected to the video monitor by a standard BNC cable, YC or S-video cable, or an RGB cable. Monitors vary from manufacturer to manufacturer, and it's a good idea to familiarize yourself with the menus and functions of the monitors being used with the endoscopic system. Every piece of equipment in the system can affect the image the surgeon relies on to perform endoscopic procedures. At this point, let's turn to the testing and troubleshooting aspect of the video camera. As the person in the hospital with the most knowledge about electronic medical devices, you will be called upon when the image on the monitor is not what it's expected to be. This can mean everything from no image at all to interference or poor color. By setting up a test bench in your lab or by using the information presented here, you will be prepared to evaluate camera systems in a lab situation or in the OR setting. You will save valuable downtime if you can resolve some of the smaller issues without sending the camera out for repair. Problems that do require opening the camera head or CCU will still need to be handled by an authorized repair service. Do not open the camera head or CCU. This will void the warranty and may introduce contaminants into the optical system. To set up a test bench, you will need the following equipment: a video monitor, a vector scope, standard lights with light deflectors using 150-watt light bulbs, the soft household type, a Hale color chart and white balance card, a vise with 360-degree lock nut rotation, a keyboard, video cables including RGB, YC, and composite, and a power cord. Make sure you familiarize yourself with this equipment and its operation by reading the instruction manuals provided by each manufacturer. Also, you should be aware of periodic calibration requirements. The standard bench setup should look like this. Note the distances for the lights and charts. A darkened room is preferable since you will be looking at a video monitor. Once the bench is set up, you can put a camera system through a variety of tests to determine if it is functioning properly. The procedures to follow will give you the basic information needed for evaluating a video system. First, hook up the video camera by running a YC or RGB cable, if available, from the video output on the back of the CCU to the video input on the back of the monitor. Plug the camera head into the receptacle on the front of the CCU. Attach the CCU video out to the vector scope input using a composite cable. Then, connect the vector scope output to the monitor. Use the color bars function on the camera control unit to properly adjust the monitor prior to testing any equipment. There are some cameras that require use of the keyboard to access the camera's functions. If this is the case, plug in the keyboard on the back of the unit. The keyboard will be functional when the camera is turned on. If the camera has RGB, put the monitor in external sync mode. You will find this on the front lower panel of most monitors. If no RGB exists, the monitor must be in the internal sync mode. Clean the optical window of the camera head with a cotton swab and alcohol solution to ensure that the lenses are clear of smudges and debris. Place the camera head in the vise and turn it on. Align the picture so that the color chart fills the entire screen of the monitor in the underscan mode. The white borders of the chart should be visible. The borders will not be visible in the normal scan mode. Using the white reflectance chart, point the camera at the chart so that the white image fills the monitor screen. Press the white balance button on the front panel of the CCU. A message will appear on the monitor, "White balance OK," with most Karl Storz cameras. Other manufacturers may have different indicators or none at all. If the message "White balance failed" appears, repeat the process, ensuring that the white image fills the monitor screen. Remove the white reflectance chart after white balancing is completed. Next, verify that the image looks similar on all outputs. Some cameras have 2 YC outputs to check. Once you have established that the outputs are working, test the color by using the vector scope. Ensure that the burst vector is even with the 0-degree axis on the scale. Check to see if the unit is centered by pulling the plug off the composite output on the CCU and making sure the dot on the vector scope is in the middle. Verify the flesh tone on the vector scope also. This is easy to do if you place a flesh-colored Band-Aid on the bottom of the color chart. Next, verify all of the camera's functions. Step through the functions located on the front panel of the CCU. You may need to reference the instruction manual to acquaint yourself with functions and how to operate them. Now, add to the system by attaching an endoscope and light guide cable to the camera head. Using the white card, re-white balance the camera with the endoscope attached. Do this by pointing the endoscope at the white card and pressing the white balance button. If done correctly, the same message, "White balance OK," should appear. If the message "White balance failed" appears, repeat the process, ensuring that the white image fills the monitor screen. With the endoscope on, verify focusing and zoom if available. Use the palm of your hand and the flesh tone reference on the vector scope to verify flesh tones. Check the camera for shorts by tapping it lightly on the palm of your hand and bending the cable. Intermittent video or interference may indicate a break or short in the cable. If this is discovered, cameras with permanently attached cables must go in for repair. So there's the basics. These tests can provide you with a lot of information about your video camera. Although the camera is part of a bigger chain, it is often considered the culprit when things go wrong. Usually, however, the camera is not at fault, and a simple adjustment is all that's needed somewhere in the system. If the OR calls you and says, "The camera is not working, there's no picture on the monitor," you will need to draw on all the information presented in this video and check piece by piece through the system. Check connections and power cords, including the camera, monitor, and any additional documentation devices being used, such as VCRs or printers. Double-check that the cables are run from video out to video in throughout the chain of equipment. Eliminating the accessories from the chain can help you determine whether the problem is in the primary system of light source, scope, camera, monitor, or if it's a problem with a peripheral device. For information on where peripheral devices fit into the endoscopic system, please refer to the schematics found in the accompanying study guide. If you see that everything is hooked up properly, but there are no indicator lights on the front of the unit, you can check the fuse in the CCU. This can easily be replaced using a small screwdriver. Fuses are available at most electronics stores, but must be of the proper size and type. Complaints of spots or a blurred picture should lead you to the cotton swab and alcohol for the lenses. The optics of the camera head and the endoscope both need to be considered. A dark image can also be the result of dirty optics and/or broken fibers in the scope or light guide cable. Poor color or inaccurate color reproduction may simply be that the camera was not properly white balanced or that the monitor is not properly adjusted. Re-white balance with every piece of equipment in place. If the problem is the monitor, press the reset button on the monitor and refer to the operator's manual for making further adjustments. The problem of interference may have to do with a short in the camera cable or with the use of electrocautery equipment. Electrocautery equipment must be connected to a different circuit than the video system to prevent interference. High-frequency cords placed too close to the camera cable can also cause interference. If you go through all of the above-mentioned checks and by process of elimination determine that the camera is not functioning properly, then take it a step further to determine whether it is the camera head or the CCU at fault. Although cameras vary somewhat from manufacturer to manufacturer, the following 4 tests will work for all camera types. Swap camera heads if a second head is available. If the same problem exists with the second head, the problem is likely to be in the CCU. If the initial problem is no longer evident with the second unit, the problem is likely to be in the camera head. Check the camera cable connectors and the connector input on the CCU for corrosion buildup due to improper cleaning techniques following disinfection or sterilization. If corrosion exists, clean the connectors with a cotton swab and alcohol solution. If discoloration cannot be removed and appears to be burned, the connector has shorted out and the cable needs replacement. If you suspect a damaged cable, manipulate the cable strain relief at the head and connector ends to look for noise or loss of picture. If the problem area is close to the head, it is likely to be a damaged cable. If at the connector end of the cable, there may be a problem in the CCU cable receptacle. Operate the focus and zoom mechanisms through the whole range to check for distortion or mechanical problems. Setting up and using a test bench to evaluate video cameras can save your hospital time and money. Many of the cameras sent to our facility for repair are found to have no problem. This is a difficult situation for us since we don't have access to the entire endoscopic system. You, on the other hand, have the opportunity to check every piece of equipment that is used in conjunction with the video camera. By following the non-invasive procedures shown here, you will be able to evaluate and test a video camera for cable integrity, optical clarity, and color reproduction. Remembering that the video system is only one piece of a bigger puzzle is the key to keeping your hospital's valuable endoscopic systems up and running.